Hey everyone, welcome to this section. Here let's go and configure the dynamic routing protocol. But before we start dynamic routing protocol, let's go and define certain key points of dynamic routing protocol. Okay, so dynamic routing, as the name says, it's like automatic way of learning the unknown networks by running or implementing some sort of dynamic routing protocols, which could be either IGP or EGP, right? So under IGP, you have categories like routing information protocol, RIP. You have Cisco proprietary EIGRP. You have got OSPF, which is Open Standard Protocol. You have got ISIS, right? And under EGP, that is Exterior Gateway Protocol, you have only one, that is BGP, right? Now I believe all of you know this concepts, but what we want is, before you start deploying RIP or OSPF or BGP on your Palo Alto firewalls, let's learn the key points or just do a recap of RIP and OSPF and all, so we know the key points, and then we can do the basic configuration. So let's go ahead and talk about the key points of RIP that any engineer must remember before it does any sort of configuration, right? So things to remember regarding RIP. So RIP stands for Routing Information Protocol, right? So RIP stands for Routing Information Protocol. So if you have, I just want to just draw for your reference over here. So I might have some couple of, or might be say 3 routers, right? Might be I have got some routing networks defined here. Okay, right? So let's say this is R1, this is R2, this is R3, this is R4, and this is R5. And behind R5, let's say I have got a destination network that I want to connect, and let's say this destination network is, as an example, this is 5.5.5.0/24, and let's say this path, whatever I'm defining here, this path starts is from 12.series network, this is 13 series network, 34, 45, and say 25. Okay, now let's say my source router is router 1, so this is acting as the source router and this is acting as the destination router. Okay, and these are the different paths I have to reach the network 5550/24. Now let's see if I run this protocol RIP on all this routers and advertise RIP on all these networks, what my best path would be. So RIP works on the principle of hop count. So if I run RIP on R1 and say that, hey, to reach 5550, it will automatically learn that it will have two paths, one via this next hop of R2 and one via the next hop of R3. But RIP uses the concept of metric as a hop count, right? So over R2 path, it will have couple of, the hop count will be like 2 hops. Okay, 2 hops of router 2 and router 5 to reach network 5.5.5.0, and over this 13 next hop, it will be having 3 next hops, so metric would be 3 over here, a 3 hop count to reach this 5550/24 network. That means lower the hop count, that is they considered as the best path. So RIP will take the route via R2 as the best path to reach this destination network of 5. Although this route will have lowest bandwidth link as compared to the other route. So let's say this is 10 Mbps link, right, and this is a 10 Mbps link as well. Okay, but over here I'm running this as a 1 Gbps link, and this is say this is a 10 Gbps link, and this is, say this is a 100 Gbps link. But the issue with RIP is, it does not understand the concept of link parameters or link bandwidth, so it goes routing by rumor concept. It has got the concept of hop count as metric. So although the the path that it can choose with a higher metric, which will have a better bandwidth, but it does not know how to choose that. That's the drawback of RIP. That's the reason why we have got other routing protocols, which is like distance vector protocols. Advanced distance vector protocols like ARGRP or OSPF. They work on the link parameters to choose the best path, right? Okay, so let's go ahead and write down those key points. Okay, so regarding RIP, as I've told you, routing information protocol. So RIP is a distance vector routing protocol, right? The first key point that comes to my mind is it is a distance vector routing protocol. Okay, number two would be it uses hop count as a metric, as its metric to calculate the best route to a destination network. Okay, third point could be routing updates. So routing updates, I can say have got this periodic routing updates, occurs every 30 seconds. So it is not that fast protocol. So if there is any changes to a network done, so RIP protocol to advertise those changes, it will take 30 seconds of time. And RIP uses an algorithm name called as Bellman-Ford algorithm for route determination. Okay, regarding the version, so RIP has got a couple of versions. So we have got, if I say RIP versions, so it will be RIP v1 and RIP v2. So where RIP v1 is classful, okay, it does not support subnet mask. That's the one thing. Where in case of RIP version 2 is classless, it will work on the discontiguous subnets, and it supports subnet mask, and also it supports authentication, right? Authentication to attach to the right routers, right, authenticated routers, and to receive authenticated based updates. That's important. And there is one more version, we call that as RIP NG or RIP next generation. Basically nothing but it supports IPv6. All right. RIP uses the hop count limit. So as I've told you, hop count is the metric. So you can say the hop count limit for RIP is 15. So it's 15 hops. If a route has 16 hops or more, it's considered unreachable. Okay. Oops. Okay. Yeah. Hop count. Similarly, convergence. Regarding convergence, I can say this is one of the slowest converging routing protocol. So the reason, because of this periodic updates and these hold down timers that RIP passes with itself of 240 seconds. Slow convergence, due to periodic updates and hold down timers. Okay, likewise, it has got multiple way to prevent loops, which is loop prevention mechanism, so which includes split horizon feature and route poisoning, right? So these two are the and also it has got another feature using hold down timer. So these three are the ways to prevent any routing loops. So in case of split horizon, it's like it will prevent the routing information from being sent back to the source from the same interface it has learned. So RIP has learned an update on the left hand interface. Let's say it will not send back the update from the same interface to the originating router. Okay, route poisoning is basically it will mark any unreachable routes with a metric of 16. So if a route becomes unreachable, it advertises those routes to its neighboring routers with a metric of 16. And hold down timer is it will prevent any the frequent route changes to stabilize the network. Okay, right. So AD value of RIP is basically 120, administrative distance value, as we say. So RIP has a default AD value of 120, making it less preferred, and it's, I can say, less preferred than protocols like OSPF, protocols like OSPF whose AD value is 110, and say EIGRP whose AD value is 90, specifically for internal EIGRP. Last but not the least, let's say it uses UDP port number. It works on UDP port number 520, and 520 is for IPv4. Okay, which is for IPv4, and it uses the UDP port number of 521, which is for IPv6. All right, so those are one of the key points that you must remember when working with RIP as the protocol. Now let's go ahead and do the configuration of RIP. I hope these points are clear. Okay, so let's go and do the configuration of RIP. So let's go to the Palo Alto firewall. Let's go to PFW1. Now what I want is regarding the RIP task is let's say I have a loopback 99 on the edge router. Okay, I've got the loopback which is 11 and 111 on the inside router. I've got a loopback on the PA firewall as well of 1 2 3 4 and 5 6 7 8, and I want to run RIP between the inside router and the PA firewall, and also between the PA firewall with the edge router, and I want to advertise RIP for all those loopback networks and on the inside link and the outside link. Okay, so let's go ahead and define the task and then configure that. So this is task, I can say RIP configuration task. So configure RIP on PA FW1, advertising its inside and outside interface and its loopback networks. Configure RIP, of course v2, because we are running classless subnet, so definitely we'll work on v2, and also we'll configure authentication. So configure RIP version 2 on the inside router, inside and the edge router, and advertise its loopback and physical interface. All right, so let's go and do that. Let's go and configure RIP first of all on the inside router. So let's log into the inside router, and I have some static routes configured earlier. So if I look into that, yeah, I've got static route. Let's remove that static routes. Let's remove that second static route as well, and do show IP route. I only have the connected routes. Let's run RIP. So router RIP, define the version as 2, make it classless, define the command as no auto summary, and let's run the RIP protocol for the network 10 interface, which is E00, and let's run for the network 11, and let's run for the network which is 111. Okay, then if I see do show IP protocols, I can see that I am running RIP as the routing protocol. It's enabled for the Ethernet 0 interface and a couple of loopbacks, routing for respective networks. AD value is 120, looks good. And likewise, if I go to my edge router over here, so let's go to the edge router. Okay, let's see if I have the loopback interface configured on the edge router, which I don't have it. So let's go and configure interface, say loopback 99 as an example, and configure the IP as shown here with all 99 and /24, and let's see if I'm running any protocol. Do show IP protocols. I don't have any protocol, so let's run RIP. So this is router RIP version 2, no auto summary. Network would be 99 and network would be 123. If I define network statements, and I hope you know that, as classless. Okay, and if I see show IP protocols, I would see that this is read as classful. Okay, it will read as per the class of this address. All right, so it is routing for the gig 00 interface and the loopback 99 interface. I can see routing for those two networks, all good. And likewise, let's go ahead and configure the PA firewall. So under network, under virtual routers, under the default virtual router where all the interfaces are belonging, I click on this RIP tab. I first of all enable this RIP. RIP is saying that I will reject any default route if it is originated from RIP process. If it's required, you can uncheck that if you need that RIP default routes, but in my case I'm fine with that. Configure BFD if you want. Now in case of RIP, your job is to add the respective interfaces who are going to be part of the RIP process. So for me it is loopback, couple of loopback holding these two IPs, and I think it's loopback 10, loopback 11 what I've configured, and it ETH1/1 and ETH1/2. So let's add those interfaces from the list. So it is loopback 10, it's enabled. I can define authentication profile, which I will discuss in some time. Hold on, I'm running RIP. I can run as normal mode where it will send and receive the RIP updates as version 2. I can make it passive where it will not send any RIP updates, but it will receive any RIP updates, and I can run RIP as send only mode. Let's say it's in Roman on the or let's say it's a loopback interface, right? So I can make it as a passive, because through a loopback interface I don't have any physical device connected, so it's a logical interface, and I can make it as a passive interface, right? So it will not send any updates, which is not required. And if you want, you can configure BFD on that port as well. Yep, let's leave it like that and click on loopback 10, enable with RIP. Likewise, loopback 11, enable, make it passive, and click on OK, and likewise add that physical interface eth1/1, and over here its enable mode is normal, click on OK, and it's eth1/2 enable mode is normal, and click on OK. Perfect. So look on the timer tab, so you can see the update interval, the hold down timers are defined here. I can configure authentication if I need, so and also I can define redistribution once if it is required. So as of now, let's run with the basic stuff. So let's go and click on OK, and then let's commit our changes. Commit all changes. You can define, and you can see the preview changes also if you want. Click on OK, and you can see what changes that have been reflected over here. So yeah, so you can see that those changes highlighted will be configured, right? That's it. So click on commit all the changes, and let's wait for the commit to complete. Okay, so I can notice here that the configuration is committed successfully. Let's go ahead and verify this. So let's go to my inside router and check if I'm receiving these routes or not. And one more thing, I should have a security policy which should allow this communication for the RIP updates from inside to outside, okay, and also from outside to inside. So let's say first, and let's verify that first. So if I go to my inside router, and if I look for show IP route complete routing table, I see that I'm receiving 123 network using RIP. I'm receiving 99.cds using RIP, okay, and I'm receiving this 1 2 3 4 and 5 6 7 8 network of this Palo Alto firewall with one hop, okay, and this is the next hop of Palo Alto using RIP. So I can filter that with show IP route RIP as well to see only the RIP routes, okay. So I can see all those routes in my inside router. Likewise on the edge router, if I look show IP route only RIP protocol, so I can see the Palo Alto loopbacks, I can see the inside network, I can see the loopback of the inside router, the respective AD value of 120 and the respective hop counts. Alright, and likewise in PA firewall, if I look under my virtual router default, click on more runtime stats, and you can see the route table with R. So R is you're receiving those route 99 through RIP protocol, you're receiving 111 using RIP protocol, right? The reason it is shown as active because static routes take precedence over RIP routes. that's the reason. The same network, if you have learned through static as well as through RIP, since static route has got a lower AD value as compared to RIP which is 120, so that's the reason the active is on the static route. All right, so you can see that it is receiving this routes using RIP, right? So both my 11 and 111 and also the destination network which is 99, it's part of the RIP process. Perfect. Likewise, you can verify this on the CLI as well. So this will be show routing route, and I can see that I'm receiving the RIP routes respectively 11 and 111 using RIP, and also 99 using the RIP protocol. All right, let's verify that from the Palo Alto itself. If I can ping, so let's say ping source. Okay, so let's say from the Palo Alto I do ping source to reach the inside router loopback. So just say 1.2.3.4 with a source of to a host of which is 11. Okay, so this is reachable. I know it is taking that static routes, but yeah, and also from this this route 99 was not known using not known using, it was known as by default route also, but it is known specifically using RIP, so we prefer that via RIP. So 1 2 3 4 to reach that 99 series loopback. Okay, all right, so we'll see that what is the stuff. So let's say from inside to outside, let us do a ping. So if I look in the inside router now, I have everything. So if I go to the inside router and do a ping to, let's say, 99 dot with the source of 11. Okay, my ping is not passing through. Probably the security policy is the issue, or might be I need to allow that particular rule back and forth to happen. All right, so yeah, so let's say if I do a testing purpose, write down a security policy for that. Okay, so if I go to the firewall policy, click on the security policy tab, and let's say that you are doing a testing for that RIP protocol. So general, it's a RIP, let's say RIP test, trust to untrust. Okay, all right, you can define this same in the description as well, that's fine. Source, let's say I add the source as my trust zone. Source address is where I add only a particular address over here, which is that IR inside router, which is 11.11.11.0. okay, so this is IR 11.11.11.0/24 network, 11.11.11.0/24 network. Okay, so I select that source, any user, any device, that's fine. Destination is going to that outside or the untrust zone. Destination address is that destination address object, which is that name, which is edge router 99.99 loopback. Okay, something like, oops, Control C, Control V. So it is 99.99.99.0/24. Click on OK. Any device, application is any, service it's any, let's say action is allow, log is enabled, that's fine. Click on OK there. Okay, so yeah, I've got a testing from 11 to 99. Let's go and commit that, commit all the changes. Let's wait for the commit to complete. It's almost on the edge of completing. Okay, so it's done successfully. So let's ready to test it now. So let's go ahead and you can see in monitor I can look for the traffic logs. Okay, and trust to untrust, yeah. So let's say that I have to go to the inside router, and from the inside router I do the test and it's working fine. My security policy is allowed, and this is a next gen firewall, so whatever traffic goes from inside to outside, it will create a session table for the same entry, and the return traffic will be automatically allowed on that particular session table. Now on the Palo Alto firewall, if I do a refresh, okay, so you can see that I have got in the monitor tab under logs, on the traffic logs, you can see that from this trust zone to the untrust zone, the source is 11, destination is 99. The ping traffic, it was allowed by this rule that we have configured, amount of bytes you have sent, etc. Right? You can verify that in much detail by clicking on this magnifier glass. Right? Look for much more information that you want. All right, we'll discuss those troubleshooting steps later. as of now, let's focus on the important stuff. Likewise, there is session browser under monitor. Click on session browser. All right, and if you can refresh that, you can also find, it might take some time, so just hold on for that. Hold on. Let's go ahead and talk about the traffic which is originating from say, edge router to the inside router. You might have that doubt. So let's say I ping from the outside to the inside router. So ping to 11.11 IP. This is the inside IP with the source of 99, but the ICMP is now getting originated from the outside. Okay, now see, this packet will not work. The reason, because I didn't allow the traffic from outside to inside in my security rule. I allowed only from inside to outside. So only if the traffic is originated from the inside, then only it will be the reply traffic, or the ICMP return packet will be auto allowed on the particular session, right? So if I try to ping from source 11 to destination 99, this will work, but but if the traffic is originated from the outside, that will not work unless and until I explicitly write down or define that in my security policy. All right, I hope it is clear. Next thing that I can do over here in this RIP is, let's say we can go ahead and talk about authentication. All right, so let's say I don't want RIP to work from the Palo Alto firewall to the outside router. Okay, so my outside router should not receive any RIP updates. So I should run RIP only between my inside router and my Palo Alto firewall. Okay, that means let's say I go and configure an authentication profile, and whenever I exchange the RIP updates, I ensure that I go along with the authentication itself, right? But there is no authentication configured from the Palo Alto to the edge router, so it will not be able to receive any RIP updates. So right now, if you look into the let's say I capture the RIP packets on my interface ETH1/1. So right click on the Palo Alto firewall, click on capture, click on ETH1/1. Let's say I open up the Wireshark over here, right? So you can see that I will have protocols that should be running. So let's say I am capturing for RIP protocol, which is RIP. So you can see that you're getting some RIP protocol response over here. So the source is 10.11.25. RIP sends update using destination IP as a multicast, so RIP version 2 update. So you can see that RIP periodic updates are happening on this particular interface. If I double click on that, I can verify those packet details. So I can see at layer 7, this is my routing information protocol. I can see it's running with RIP version 2. These are the updates which I'm receiving for my IP address with the right metric, and I can see it's part of UDP 520, the source IP and the destination IP in the packet, the layer 2 information, right? So I can decode that, right? So I can understand how my RIP packets are getting updated here. Perfect. So okay, let's close this, or let's stop this particular session for time being, and let's run this particular authentication between the inside router and my Palo Alto firewall. So my next task is configure RIPv2 authentication between the inside router to the PA FW1, and share the edge router should not receive any RIPv2 updates. Okay, so let's go and configure that first on my router, and then we'll go and configure on my Palo Alto firewall. So let's go to my inside router and first define the configuration commands. Okay, so first we'll define this as a keychain. So we'll define a keychain which will hold the authentication key. So first command is keychain. Let's say it's very simple. It's the keychain name is rip_auth and the keychain name is case sensitive. I define the key ID, which will hold the key string, which is, say, as an example, Cisco123, all in lowercase. All right, so I define the keychain, the key ID, and the key string, and then I am going to the interface on which authentication has to be configured. That's my interface e0/0. I should say IP rip authentication. I can define mode, so either I can go with clear text, which is not recommended, because if it is clear text then it will send in the RIP updates authentication password in clear text as well. So anybody sitting man in the middle can capture the packets and can understand what's my password is, which is never a safe thing. So mode, let's say I go with the MD5 process, which will actually hash my secret that I've configured. Okay, so mode is MD5, and then I define the keychain which I have used. So IP rip authentication, define the keychain. In my case, the keychain was RIP_auth. Be careful, it is case sensitive. So whatever parameters are defined in this keychain, we have defined over the interface over here. All right. So to verify, you can do multiple commands. So first of all, you can define show keychain. Okay, you can see that the keychain name is RIP_auth, the key whatever you configured, and you can run debug IP rip command on Cisco routers. You can do show IP protocols, and define that routing protocol is RIP, and you can see the interface e0/0 is running with an authentication keychain right here. Okay, now what will happen is because of this, if you do clear IP route star, if you just clear the routing process or the routing table, and if you see show IP route, you don't have the RIP updates right now. Okay, and if you do debug IP rip, so what is happening over here is you are sending over e0/0 the routing updates using the authentication process, right? But you are receiving the routing updates from the Palo Alto firewall without any authentication. So in that case, we'll ignore that, right? So you'll ignore that routing update. That means you can see right here, I just do an undebug all. I can see that I'm ignoring v2 packet from 10.1.1.2.0.1, which is my firewall, and I'm ignoring that because it is having invalid authentication, right? Likewise, you can do a packet capture as well. So I can capture the packet, which is right here. That's okay. So capture the packet eth1/1 interface, let's say. All right, I'll just filter for RIP. It takes 30 seconds of time, so you need to just have patience. Yeah, so you can see that you are receiving 10.1.1.25. This is a source. You are sending some updates. So let's open up the packet over here, and if you look under RIP process, you can see there is an authentication which is defined as MD5, right? And you are seeing the routing update that you are receiving, but you are not going to keep it, right? You are not going to keep those as routing updates. Okay, so if I look into, but when you are sending, so for example, open that packet, when I'm sending as a Palo Alto firewall, when I expand that, I don't see any authentication that I'm adding to my version 2 updates, right? So I'm sending my network information, etc., but I'm not, I can see I'm sending 1 2 3 4 5 6 7 8, etc., but I'm not adding any authentication to my response, which is not right. So that's the reason. What you should do is you can go ahead and enable authentication on your PA firewall. So on PA firewall, what you do is, you go to the network tab under virtual routers, default virtual router where the RIP is configured, RIP process, click on the authentication profile here and click on add. Okay, so let's say this is, you can give same name or different name, so I like to keep same name as RIPauth. I can make it as MD5, right? And I'm adding the key ID, say key ID 1, and my key string should be same, Cisco 123 all in lowercase, Cisco 123 in lowercase, and click on OK. Click on OK there. So my key ID key string is configured, my authentication profile is configured. Now I should enable this on 81/1 only. That means under RIP, under the interface, under 81/1, under authentication profile, make sure you enable that RIP auth. Click on OK there. Click on OK there. Ensure you commit the changes. You can do preview changes now. Do you see what changes will be applied? So you can just scroll down, you can see authentication RIP will be applied to the candidate, to the running config from the candidate config. Again, this is the authentication profile, and you can see since I've added MD5, so the keys are getting hashed out. All right, let's go and commit that. Okay, and by the time it gets committed, let's go to my edge router and verify that I'm not receiving. If I see show IP route RIP, I should have 1 2 3 4 5 6 7 8 right here on the interface. Okay, so I'm receiving the Palo Alto updates, that's fine, I mean but I'm not receiving the inside updates over here, right? So see that loopback 11, loopback 111, those routes are not available over here. Okay, looks good. Looks good to me. So let's go to the Palo Alto firewall and wait for the commit process to complete. Okay, so the configuration is committed successfully, and now if you look into the inside router, which was not receiving earlier, it was not receiving the RIP updates because of authentication failure. Now show IP route RIP, I'm receiving the Palo Alto updates. Okay, and also 99, because 99 is appearing to Palo Alto firewall and it is forwarding the update to me. But ensure that the edge router will not have any RIP updates about the inside router. So I'm showing a complete routing table to you. So regarding 11 and 111, it will have those routes gone because it will be part of that. So what you can do better is add that authentication profile on ETH1/2 again, right? So let's say I just go to my Palo Alto firewall on the default VR under RIP under ETH1/2. Let's add that auth profile, which is RIP auth. Okay, and click on OK there. Click on OK, and let's commit the changes. Let's wait for the commit to complete, and then we'll verify that on the edge router it is not receiving any RIP updates from that PA firewall. Okay, so the configuration is committed successfully now. So now you can do what, you can go to my edge router and just run clear IP route star and just run debug IP RIP. So you can see that it should ignore that RIP version to update whatever it's receiving on the edge router because of authentication failure. Because I'm running authentication on E1/2 and I don't have the same on the edge router for gig 00. I can see that it is ignoring that. Okay, because of which if I see show IP route RIP now, I should not see any RIP updates in my routing table. Okay, and likewise if I look into my inside router, which was having that 99, right, even my PA firewall will ignore that. So if I see show IP route rip. Sometimes it takes a bit of time, yeah, but it is fine now. So you can see that I'm not receiving that 99 route in my inside router routing table. Perfect. So authentication is happening perfectly, RIP is working perfectly, and you can see that inside router can also reach 1.2.3.4 with source of 11. So inside to the Palo Alto firewall loopbacks are working fine. So thank you for watching. I'll see you in the next lecture. Please practice it, and if there is any queries, we are here to help you out. Thank you, and see you in the next video.